Hi guys, I wanted to make this video to address this past paper question from an OCR paper, and it's one that a lot of students find quite tricky. It's about shapes of molecules. So before we start looking into this, let's define what we mean by planar. A molecule can be defined as planar if it's two-dimensional. In other words, if we were to make a model of the molecule, it would lie flat on the table with no bits sticking out. Linear, nonlinear, and trigonal planar molecules are all examples of two-dimensional planar molecules. So if we look again at the question, we could draw out the structures of these, the structural formulae. And we can do this by bearing in mind how many bonds each of these common elements form. So carbon forms 4 bonds, hydrogen forms 1, oxygen forms 2, and nitrogen likes to form 3. And we end up with these structures. So if we look at compound A, we've got 3 bonding regions. So in terms of shapes of molecules, a double bond behaves pretty much like a single bond. So we count this as 3 bonding regions and 0 lone pairs. So that gives a trigonal planar shape with bond angles of 120 degrees. So A is planar, and the question's asking which is not planar. If we look at B, we've got 4 bonding pairs around each of the central carbon atoms and 0 lone pairs. Anything with 4 bonding pairs and 0 lone pairs has a tetrahedral shape with bond angles of 109.5. Now that is not planar, that is actually 3-dimensional. So the answer is B. And just for completion, to look at the last two, C, this is planar because we've got 3 bonding regions again. So this would be a trigonal planar shape with bond angles of 120. And D, that is linear with a bond angle of 180. And these are planar 2-dimensional shapes as well. So the correct answer is B. Hope that helps. See you again soon. Bye.